All right, we are going to talk about patterns and relationships. Let's go. So, our essential question: how can we use mathematical relationships to predict how changing one variable will impact another variable? I want to preface this video with a couple things. First of all, this is truly an introduction to the patterns that we're going to see. We're about to do a series of labs to introduce each of these patterns separately. So you are not expected by the end of this video to have a really complete understanding of each of these patterns. What you should be able to do, if you preview page 15 of your notebook, you should see that in those relationship practice problems that you should be able to identify how changing one variable will affect another variable and being able to name the type of relationship for that. All right, let's get started. Relationships matter. Let's talk about it. So, the goal of physics is to be able to explain the past and predict the future. That's all we're doing in all of our labs. To do this, we need to find out how changing one variable impacts the other variables. So you will usually have our independent variable that will change and one dependent variable that we measure. We see how that was impacted by changing the other one. So a connection between two variables is called a relationship, and it's the building blocks of an equation. We are constantly seeking to understand the relationships between things in science. In general, we want to know if increasing one variable, so if we increase one variable, that independent variable, is it going to increase the other one? Is it going to decrease it? Or will it have no effect on the other variable? That's the big idea, and that's what we do science for. So let's talk about some of these relationships that we have. Some variables, when you compare them, when you change one thing, you realize that it has no relationship with the other thing. So that means that changing one variable has no impact on the other variable. Here's an example of that. The length of your hair has no relationship with the grade you get on your physics test. This woman and this woman are both equally likely to be physics rock stars. They've got different hair, no relationship between it. All right, some variables have a proportional relationship. What does that mean? It means that increasing one variable will increase the value of the other variable by the same percent. What does that mean? Okay, so for example, the number of people in class has a linear relationship with the number of shoes in the classroom. Let's take our friend here. We have one person and there are 2 shoes in the classroom. Right, now let's say we have a classroom of 4 people. So we have 4 times that one person gives us 1, 2, 3, 4 people. And that means that we would then, to find out the number of shoes, we multiply by the same number. 4 times 2 would give us 8 shoes. 1 person, 2 shoes. 4 people, 8 shoes. Some variables have an inverse relationship. And sometimes this is called an inversely proportional. We just call it an inverse relationship in this class. Okay, what does that mean? It means that increasing one variable will decrease the value of the other variable by the same percent. Now, something that could be helpful, draw little arrows in your notes, draw the little down arrow next to inverse. That can be helpful. I'll just go ahead and do that on my screen. Here's some variables have an inverse relationship. That means that as one variable goes up, the other variable goes down. You can kind of think of it that way. And you could draw, for the previous one, for proportional, 2 up arrows. Okay. So here's an example. The amount of dinner each dog in a family gets has an inverse relationship with the number of dogs sharing dinner. All right, here's our one dog. Little Rex here is super happy to be eating that one dinner. One dog, one dinner. Sorry, it's a little covered up there, but one dog, one dinner. If we have 2 dogs, Rex looks really annoyed because now Rex needs to share with Rory. And now we have 1 dog times 2 is 2 dogs. But one dinner divided by 2 is the amount of food that each dog gets. Each dog gets half a dinner. because the number of dogs doubled, the number of dinners halved. All right, and this last one, this is probably a kind of a tricky one. Some variables have a quadratic relationship. This is probably something you haven't seen this kind of relationship in math yet, but you will. So some variables have a quadratic relationship, which means that doubling one variable will quadruple the value of the other variable. Okay, here's an example. The number of days that has passed has a quadratic relationship with the amount of mold that grows on an orange. So we got our orange on day 1, and by day 4, by day 2, there's 4 times as much. Now, these are just some random pictures of an orange, but what I want you to get with this relationship is that it's really fast. It's really, really fast growth. And there are some examples in physics of quadratic relationships, and, we'll get to those. So I don't want to spoil it for you. So, in summary, to revisit the essential question, how can we use mathematical relationships to predict how changing one variable will impact another variable? I'd like for you to pause the video here and attempt that, or to write that conclusion, that summary. And then I'm going to show you, go back to this video because I want to give you an example of how to do the relationship practice problems. They're a little bit funky, and you'll definitely want to practice before you jump right into the mastery check. So directions. Predict if and how changing one variable will affect the value of another variable using a mathematical relationship. Ahmed and Bartolo each go running. They run for 30 minutes, and in that time, Ahmed covers more distance than Bartolo. Compare the change in distance, the average velocity, and the change in time values for the two people. Okay, so I'm going to go ahead and mark up my screen. And this could be helpful to maybe have some different colored pencils just to kind of focus your notes, but that's up to you. So they run for 30 minutes. That is a measurement of time. Okay, so we're focusing on that change in time. It looks like it's the same for both of them. They both ran for 30 minutes, so I can go ahead and mark same. Ahmed covers more distance than Bartolo. Okay, so Ahmed, more distance. All right, so then my change in distance, that would mean that we have more, and Bartolo ran not as far, less of a distance. Okay, so then we have to think about what does that tell us about their velocity? Well, if Ahmed covered more distance in the same amount of time, Ahmed must have been going faster. So velocity is speed. Speed. So Ahmed must have been going faster, so that's going to be more. And that also means then that Bartolo was going slower, that's less. Okay, so what kind of relationship does this demonstrate about the variables? Now, when you're thinking about which variables, you should think about the two that are different. So it's not, we don't care about the time, that is the constant. And I know we haven't talked about that, but what we care about is distance and velocity. There's another thing here in your notes. I'd like for you to just go ahead and cross out quadratic in your notes for all of these practice problems. It's hard for you to tell whether something is, so if it's proportional, it means that it is increasing, right? When one increases, the other one increases. Quadratic also means the same thing, and I don't want you to get confused about which type of increasing relationship it is. So we're just going to go proportional, inverse, or no relationship. Okay, back to this. If it's proportional, it means that as one variable increases, the other variable increases. If it's inverse, it means that as one variable increases, the other variable decreases. And if there's no relationship, then that would mean that as one variable increases, the other one stays the same. So I'd like for you to think about the, what is different about here. So we've got, we were told that Ahmed covers more distance than Bartolo. We see more and more. That tells me they're both doing the same thing. It must be a proportional relationship. proportional. I'm going to let you write that in. It's going to be sloppy on here. Please write in proportional on your notes. And then we need to think about the first and the second variable. Okay, so we were given that Ahmed covers more distance. That's going to be the independent variable. So when you are given one of those things, that should become your independent variable for these practice problems, okay? So we know distance, so we're going to put in distance here. Okay, great. There's my distance. Y'all are going to get really good at learning how to read cursive. Okay, so distance and velocity is the second one. Velocity. And I'm going to get better at writing in cursive on the computer. Okay, but I didn't that time. Okay, so that is how you'll do these practice problems. I really recommend that you do them. You check them with somebody else before you do that practice mastery check. The mastery check. All right. Good luck.